list. You are given the head of a singular linked list. The list can be represented as node 1, node 2, node 3, etc. etc. So basically, we're giving a list, for example, 1, 2, 3, 4. We want to reorder to be 1, 4, 2, 3. So 1 and then last node, and then second and second to the last, and then this is the question. And then for this question, I'm gonna separate into different steps. I'm gonna first find the middle of the linked list, and then I'm gonna split the linked list into first half and the second half, and then I'm gonna reverse the second half of the linked list, and then I will iterate through both linked lists, and then generate and then change the pointer so I can merge two linked lists. First, let's start coding. So first, I want to find the middle. So to do that, I will have used the slow fast pointer method. So I will have a slow pointer point to the head, and then I will have a fast pointer also point to the head, and then also I want to have a list node called first half tail, so I can keep track of the tail of the first half. It will be initially be now, and then I will say, well, fast not equal to now, and fast next not equal to now. I will update the first recorder. Actually, I will move slope one node at a time, and then move fast two node at a time. And then also before I update slow, I want to keep track of the slow. So I will say first half the tail equal to slow. And then after the while loop, my slow should be at the head of the second half linked list. So I want to separate those two lists. So to do that, I will just say first half tail dot next equal to now. And then next step is I'm gonna reverse the second half. To reverse that, I will have a field pointer, I will have a current point to slow, and another one, I will have a previous initially point to now. Then I will start the while loop. So while current not equal to now, then I will first have record the next node position. So I will say temp equal to cur.next, and then I will say cur.next equal to previous node, update to current node, and the current node update to temp node. After this process, the second half is reversed. Next step is to merge. So to merge, we first make sure to get a head of both lists. So for the first half, the head will be the original head, and then for the second half, the head will be the previous node, and then after we get that, we can have a while loop. So while true, inside the while loop, I will say first, for example, for this example, we have 1, 2, 3, 4. So after the first two steps, we have first half 1, 2, second will be 4, 3. So we want 1 point to second half head. So also before do that, we need to keep track of the next node so we don't lose the reference. So first we have a list node. I will call it temp1. It will be storing the next node. So I will say temp1 equal to first dot next. After doing that, I can change the pointer. So first dot next will point to the second, and then after that I will update the first node. First node equal to temp1, and then I will do the similar things for second list. So temp2 second dot next, and then second dot next equal first, second equal temp2. But there are some edge cases we need to take care. For example, we need to have a terminal condition. So let's say when we add 2, after that we first will track the next position, which is now. So here temp1 will be now, and then after we change the pointer, we update the first to now. That means the first list is we reach the end. So that means the merge process is complete. We don't need to do anything because we don't want continue make the second list point to now. So in that case, we can say if first equal to now, we know we finished, so we can return. And then actually we can say break. Yes, so we break out the while loop, and then this is how we code it. So lastly, let's handle some edge cases. So if head is equal to now, or head dot next equal to now, that means it's an empty linked list or linked list with just one node. In that case, we don't need to do anything, so we can just return. And then lastly, the time complexity will be of n, even though we have 1, 2, 3 loop, which is 3n, but we drop constant, so it's become n. And the space complexity will be O of 1. As you can see, we do all this in place. We didn't create any other data structure, so it's used constant space. Next, let's test this code. Before, let me go through one last time. Let's submit. We passed the test.